So shear example 2. Continued. 4. So we have this section here. And then we worked out the neutral axis was here. We want to calculate the stress at the interface. So we worked out the first moment of area around the neutral axis. So we did this in two ways. We worked out the first moment of area of that section there around the neutral axis. And then around the neutral axis we also worked out the first moment of area below the cut around the neutral axis there. So the position of the cut was 37.5 millimeters. So the distance up there was 37.5 millimeters. And then remembering that the axis is y upwards from the neutral axis, so that would be our y-axis, and then that one also would be our y-axis. So that distance there, of course, is also 37.5 millimeters. Then when we worked out S dash, so when we worked out S dash at a distance of 37.5 millimeters, for the first section we got a value of 6.25 times 10 to the 5 millimeters cubed, and in the second way, when we worked out S dash at 37.5, using the bottom half underneath the cut, so of course remembering that we're doing the cut here, so that was above the cut and below the cut, we also worked out a value of 6.25 times 10 to the 5 millimeters cubed. So no surprise that the two values should be the same. Now let's now work out the stress. So let's calculation of shear stress. Below the cut or below the glue. So for that one there, we have our section like there, so that's the glue again with the neutral axis. So we've got a value of tau at 37.5, and that's going to be equal to V multiplied by S dash divided by I multiplied by B. So from before, we know what our value of I is. So our value of I, which we calculated before at the start, our value of I turned out to be 1.135 times 10 to the 8 millimeters to the fourth. Our value of V was 10 kilonewtons, and our value of S dash at 37.5, that worked out to be 6.25 times 10 to the 5 millimeters cubed. And then our B in this case here, below the cut or at the glue, so we're in this section here, so we therefore use the value of that value for B because that is just below the glue or below the cut, and our value of B in that case was 50 millimeters. So our B is 50 millimeters. So when we work out our stress, just below the glue, we will get a value of the shear stress being 1.101 Newton per millimeter squared. Now we do our calculation of shear stress above the cut or above the glue. So in this case here we have a section like there, and that's coming down like there as well, and we're in the top portion, just that being the neutral axis of the section. So again, tau at 37.5 millimeters is going to be equal to V times S dash at 37.5 divided by I multiplied by B. So our I is the same, times 10 to the 8 millimeters to the fourth. Our V is also 10 kilonewtons. Our S dash doesn't change, that's 6.25 times 10 to the 5 millimeters cubed. And our B in this case here, we'll be using that value of B, and that value of B is 200. So in that case that value is 200 millimeters. So when you put that through the calculation, that would come out as 0.275 newtons per millimeter squared. So the answer, the required glue strength is obviously that value there. So we want the glue to be able to take 1.101 newtons per millimeter squared. Before we finish, let's just draw out the beam again. So we have our beam there. We have our neutral axis here, passing through the centroid of the composite section that we've calculated, and we call that the y-axis, and then so I'd also call that the y-axis. And then if I'm drawing a plot of the shear stress, as before, the shear stress would be 0 there. That value of the shear stress is going to be 0.275, and then suddenly below the glue it jumps up to a value of 1.101 newtons per millimeter squared, and then it comes down to a maximum value at the centroid or at the neutral axis, and the maximum value was 1.163 newtons per millimeter squared. So I'm just doing that on the axes, so that would be 2.275 newtons per millimeter squared, and then the units of stress of course is newtons per millimeter squared. So that would be the shear stress distribution plotted along of the beam, and we can see each of the values that we have calculated.